Have you ever thought about how you build something massive, like a skyscraper? You wouldn't use one single mile-long brick, right? Of course not. Well, in the world of software, some programs have millions of lines of code. They're basically digital skyscrapers. So how on earth do programmers build these things without the whole structure just collapsing into a chaotic mess? Seriously, think about a modern video game you love or some complex app you use every day. We're talking millions upon millions of instructions. If you just tried to write that from line 1 all the way to the millionth, you'd end up with an impossible, tangled nightmare. So how do they pull it off? Well, the answer is actually pretty elegant. Instead of one gigantic runaway script, programmers break the whole problem down. They build with these small, self-contained, and this is the key, reusable blocks of code. This whole idea is called modularization, and it's really the secret to taming all that complexity. So the fundamental tool that makes all of this possible is what we call a subroutine. You can think of it as the individual brick, the foundational building block that you use to construct that massive software castle. A subroutine is essentially a mini program that lives inside your main program. It's designed to do one specific job, something like calculate the sales tax or show the welcome message. And the beautiful part is you can call on it to do that job anytime you want, as many times as you need. Yeah, this is the perfect way to visualize it. Your main program is running along, line by line, doing its thing. But when it hits a call to a subroutine, it takes a little detour. Execution jumps over to that block of code, runs all the instructions inside it, and then jumps right back to where it left off to keep going. Now, before we see this in action, we've got to talk about a really important concept, scope. Just think of it like data privacy. On one hand, you have global variables. These are public knowledge. They're out in the open, where any part of the program can see and change them. But on the other hand, you have local variables. These are like private secrets, locked away inside a subroutine. They only exist while that subroutine is actually running. And this is so important for keeping our building blocks separate and preventing them from accidentally messing with each other. All right, let's get into our first type of subroutine, the procedure. A procedure's job is super simple. It just does something. It's all about taking action. Check out this simple example. Up top, in the main program, the code just asks for 2 numbers. Then it makes these 4 simple calls: add, subtract, multiply, and divide. See? Each of those is a call to a separate procedure, like the add procedure you see right below it. That procedure just takes the 2 numbers, adds them up, and prints the result. Notice how clean and easy to read the main program is? It's just a list of commands. And this visualizes that detour we talked about perfectly. The main program is cruising along, it hits the add command, and whoosh, execution jumps over to the add procedure. That little block of code does its job, and as soon as it's finished, control jumps right back to the very next line in the main program. Simple as that. Okay, so that last example worked because the procedures were using those global variables that everyone could see. But, that's not always the best way to do things. What if a procedure needs a specific piece of information from the main program to do its job? How do we actually hand that information over? The answer is something called a parameter. So look here on the left, the main program is calling the tax procedure. But see how it puts the salary variable inside the parentheses? It's literally passing that value over to the procedure. Then, the procedure on the right catches that value in its own private local variable called s, and it uses that for the calculation. This makes the whole thing way more flexible and self-contained because now it doesn't need to rely on some global variable. Okay, so procedures are fantastic at doing things, but what if we need a subroutine to do some work and then give us an answer? Well, for that, we need our second type of subroutine, a function. And this, right here, is the single most important difference. A procedure just performs a task, and that's it. A function performs a task, and then it hands a result back to whatever called it. The magic word to remember here is return. Let's see this in action because it makes it really clear. The main program on the left needs to figure out a new salary. So it calls the tax function, passing in the salary. Now, the function on the right does its calculation, and then, here's the crucial part, it uses that return command to send the calculated value right back. The main program then catches that value and can store it or use it. It's a two-way street. You send data in, and you get an answer back out. So let's just put it all together. A procedure is like giving a command. You're saying, hey, go do this. A function is more like asking a question. You're saying, hey, what's the answer to this?
They're both subroutines, they both work like detours, but a function always gives you something back in return.
So we've gone through the how of all this, but the why is honestly even more important. Why go to all this trouble of breaking our code up into all these little blocks? Because it fundamentally changes everything. Your code instantly becomes more organized and easier to read instead of that tangled mess we talked about. If there's a bug in your tax calculation, guess what? You know exactly which block of code to look in, the tax function. And best of all, you get to reuse these blocks. If you need to calculate tax in 10 different places in your program, you don't write the code 10 times. No way. You write one function and you just call it 10 times. It is so much more efficient, clean, and powerful. And really, this is the core takeaway. This isn't just some clever little trick. This is a foundational principle of good programming. Building with small, focused, reusable parts is the only sane way to build anything complex, whether it's a piece of software or a skyscraper. And that brings us to the final thought I want to leave you with, this idea of modularity. It goes way beyond just writing code. Think about any complex project in your own life, planning a big event, writing a report for work, even just cooking a complicated meal. What are these subroutines? What are those small, repeatable tasks that you could define to make the entire process simpler and a whole lot more manageable? Thanks for watching.